All right, section 6.3, trig functions of any angle. What's an angle? That seems like such an easy question, doesn't it? What's an angle? You know one when you see one, right? There are lots of things like that in math. What's a circle?
Shape.
It's a shape. Be more specific. A triangle is a shape, but a triangle is not a circle.
It's just a circle.
Just a line.
Perfectly round.
Yeah.
So the parabola. Parabolas are round. There's no corners on parabolas.
Completely even. There's no
Yeah, see, I told you, there are things in math that we know them when we see them, but they're very hard to define. Circle is one of them, an angle is one of them. So
They're all too abstract.
So what's an angle? It's a triangle without a third edge.
That's actually right.
That's actually correct, but not usually the way it's described. An angle is the amount of rotation between two line segments which have what are known as the same terminal point. This point right here is called the terminal point. So that's what an angle is. The angle is the amount of rotation between two rays with the same terminal point. Now, in this class, and in most situations, when we draw angles, we draw them on our standard Cartesian coordinate plane. And how do we usually draw angles? Usually, one of our terminating rays, is usually the positive x-axis. So typically we draw angles like this, and we might call this angle theta. So we only draw one ray, and it's assumed that the other ray is always the positive x-axis. And when we measure in this direction, when we measure counterclockwise, we call those positive angles. So we measure counterclockwise is positive. Which means if I measure clockwise, I'm measuring negative. Now notice this angle that I've drawn theta here using this ray. I can measure it in this direction with a positive angle, or I could measure it in that direction, hitting the same ray, measure that with a negative angle. I'll call that angle beta. And there's a name for that. There's a name for two angles. These are different angles. This one's a positive number, this one's a negative number. There's a name for two angles that share the same ray.
Coterminal?
Coterminal. These are called coterminal angles. Two angles which share the ray. Okay, so I'm going to draw an angle for you here. Here's an angle, and I'm going to tell you that that angle happens to be 23 degrees. Believe it or not, that's 23 degrees. So a coterminal angle, if I wanted to measure in the other direction, this angle, you're absolutely correct, this angle would be 360 degrees minus 23 degrees. What's 360 minus 23? 337. So a coterminal angle would be 337 degrees. That's not right. Why is that not right? Because it has to be negative. So I should not have done 360 minus 23. Rather, I should have done 23 minus 360. So that's not the right answer, but you had the right idea. I should have gone 23 minus 360, and written it as negative 337 degrees. Those are coterminal. So make sure you get your order correct. You got to get your order correct to get the right sign. So negative 337 degrees and 23 degrees are both coterminal. Can you give me another angle that is coterminal to 23 degrees?
383.
And how'd you get 383? You could go all the way around once, which would be 360 degrees, and then go that 23 degrees. So another correct answer would be 360 degrees plus 23 degrees, which is 383 degrees. That would be another coterminal angle. How many coterminal angles are there to the angle 23 degrees? How many? So far we have 2. Are there more? I want to say there are. Can you give me another one?
You just keep going around and around.
If I only went halfway around and then went 23, I'd actually end up over here. So that one wouldn't be coterminal. But that one's very important. We're going to talk about that in a minute when you have ones that go in a straight line like that. I liked your answer. Your answer was I could go 2 times around and then 23 degrees, which would be how much? 720 plus 23 would be 743. Or another option would be I could go negative 360 degrees and then another negative 337 degrees, and that would also be coterminal. So if I give you the angle 23 degrees, how many coterminal angles does it have? It has an infinite number, because I can make as many rotations as I want and then go back to 23 degrees. There are an infinite number of coterminal angles. That's correct. So it's a trick question. It wasn't a single answer. Questions on that? All right. Now, let's say I give you another angle here. I'm going to give you this angle theta. I don't know how many degrees it is. And I'm going to give you a point on that ray, right there. Somebody give me some reasonable numbers. What are some reasonable numbers for that point right there? 5. I don't want it to be 5.5. Let's make it 5.6. So I gave you a ray, and I gave you a point on that ray. I want you to tell me the sine of angle theta, the cosine of angle theta, the tangent of angle theta, and of course the other 3. You could give me the other 3, but to save a little writing here, we're only going to do 3 of them. What do you do?
First you want to
Okay, and how am I going to do that?
you know the vertical side is 6 and the horizontal side is 5. So you can find the hypotenuse and then you can just do sine, cosine, all that stuff.
So what you did is you drew a little line going straight down like that, and you made yourself a right triangle. And then you said, well, if this is 5, then the horizontal distance has to be 5. And if this is a 6, the vertical distance has to be 6. And now I have all my right triangle stuff that I like so much. I go to my good friend Pythagoras. And how long is that? Square root of 61. Okay. So what's the sine of that angle? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent? Opposite over adjacent. Now, typically, here's what we do. Here's some new angle theta. And again, I'm going to give you a point on this, except I'm not even going to give you numbers, I'm going to give you letters. We typically call those x and y, which means this is x, this is y. If you knew x and y, could you find the hypotenuse? Yeah, you'd use Pythagorean theorem. And typically we call that distance r. Anybody know why we call it r?
It's the radius.
It's the radius. It's the radial distance from here to there, called the radius. All right, so for that angle, what's sine of theta? Using the letters. Y over r. Opposite over hypotenuse. Cosine of theta is x over r. Tangent of theta is y over x. And of course I can do the other three, and I'm going to write them down just so we write them down once. Cosecant of theta would be r over y. Secant of theta would be r over x. And cotangent of theta is x over y. That's the definition we're going to use for the sine of an angle, even if the angle is not an acute angle. What I mean by that is, let's say I gave you this angle theta. And I gave you a point on the ray. Once again, somebody give me some reasonable numbers here. 10 and 12 are not reasonable numbers. Negative 10 for x might be a reasonable number. And then how about a reasonable number for the y? 3, I think, would be a reasonable number. All right, so in other words, we have x is negative 10, y is 3. What's r? I have to find r. How do I find r? I use the Pythagorean theorem, and I get?
Wouldn't you make, like, if you did this with the figures, you're going to the negative 10, positive 10?
Well, does it matter? Because in the Pythagorean theorem, I would take x and I would square it. What's negative 10 squared? Turns out to be all positive anyway, doesn't it? So negative 10 squared is 100. 3 squared is 9. So I'm going to get square root of 109. All right. What's the sine of theta? Sine of theta is opposite, which is the y number. The y number is always the opposite. The y number is 3 divided by the hypotenuse. The hypotenuse is the r number. So sine is always going to be opposite over hypotenuse. That's going to be y over r. Y is 3 and r is square root of 109. Y over r. Cosine of theta is x over r, which turns out to be negative 10 over square root of 109. So notice that cosine turned out to be negative in this area. Why is cosine a negative number?
Because it's in a quadrant.
Because x is negative and cosine uses x. So cosine turns out to be negative in quadrant number 2. And go ahead.
Does the theta go all the way, like, it goes all the way to the x-axis, right? Then it's like we're solving the theta, but it's like
Right.
showing that it's on the other angle, like the obtuse one.
Right. This angle theta that we're looking at is this obtuse one. This angle here is something very important. That angle there is called the reference angle.
It's the reference angle.
And we are going to talk, oh, maybe not today, but sometime soon, we're going to talk in great detail about the reference angle. The reference angle is a very useful thing. Okay, finally, what's the tangent of theta? It's going to be y over x, which is 3 over negative 10. We would usually write that as negative 3/10. Questions on that? Okay. Here's a very famous chart that you always see in trigonometry. Anybody know what this very famous chart stands for?
Where the cosine, well, it sounds like positive and negative.
All right, so what's the A stand for?
All.
All. A is all, S is sine, T is tangent, and C is cosine. Now what does it mean? In quadrant 1, what does all mean?
All of them are positive.
All functions are positive. All trig functions are positive. Why in quadrant 1 are all the trig functions positive? Because x and y are both positive in quadrant 1. That's correct. Here in quadrant number 2, the example we just did in quadrant number 2, we saw that sine turned out to be positive, but cosine and tangent were negative. How come sine was positive, but cosine and tangent were negative? Y is positive here, and x is negative. And x is used for both cosine and tangent. So that's going to make these come out to be negative. So what the S stands for is sine is positive. The T stands for tangent is positive. Why is tangent going to be positive in quadrant 3? What can you tell me about a point over here in quadrant 3? This might be, for example, the point -4 and -1. Both x and y are positive, are negative. So why is that going to make tangent to be a positive thing?
Because it uses opposite and adjacent.
Because it uses opposite and adjacent. Tangent is y over x. When I divide two negative numbers, I get a positive answer. And finally, the C stands for cosine. Because what happens in quadrant 4 is the x's are positive and the y's are negative, and cosine uses x. So it's going to be a positive one. All right, once again, I've seen many different acronyms to help remember this. Anybody heard any of the acronyms?
All seniors take cocaine.
That's a new one for me. All seniors take cocaine. That's a new one.
All students take calc.
All students take calculus, which of course isn't true.
Another stupid teacher chart.
Another stupid teacher chart. I've heard that one before. That's a good one. All smelly turtles crawl. All right, that's a good one. Here's the one my teacher taught me when I took trigonometry. My teacher taught me Albany State Teachers College, because that's where my teacher had gone to college. My teacher went to Albany State Teachers College. It's no longer called Albany State Teachers College. It's called University of Albany. But when he went to it, long time ago, long time ago, it was called Albany State Teachers College. Of course, that one doesn't work anymore because there's no such thing as Albany State Teachers College anymore. But that's how I learned to remember it. But I like another stupid teacher chart. That's a good one. Works out well. All right, so here's the kind of problem I might give you that would use this. I'm going to tell you that cosine of theta is -3/5, and theta is in quadrant number 3. I want you to tell me the value of sine of theta and the value of tangent theta. And of course, I could ask for the other 3 if I wanted to, but I'm going to ask for 2. What would you do? I would draw a picture. I like pictures. What do I know? Theta's in quadrant 3. All right, so I'll draw something here that's in quadrant 3. So here's my angle theta. What else do I know?
Adjacent.
I know adjacent and hypotenuse, which is another way of saying I know. Which 2 letters did you just tell me?
Oh, X and Y.
Not X and Y, but you were close. X and hypotenuse is R. So I can mark a point right here. If I mark this point right here, I know the X is -3, and I know the R is 5. That's the information I'm given. I'm given the X is -3 and the R is 5. From that information, can I find Y?
So you have to memorize X, Y, and X.
Absolutely. You're going to need to know that cosine is X over R and sine is Y over R, so on and so forth. So there's another bunch of facts for you to memorize. Yep. Lots of memorization in trigonometry. Lots and lots more. Okay, how am I going to find the Y value now? I'm going to use the Pythagorean theorem. X squared plus Y squared is R squared. It's the formula, the form of the Pythagorean theorem we use. So I'm going to have -3 squared is 9, plus Y squared is 25. So Y squared is 16, which means Y is not 4.
-4.
In this case, Y has to be -4. Why in this case does Y have to be -4? Because we are in quadrant 3. So the sign, when you take square roots, typically you do plus or minus. You're going to pick the sign depending on which quadrant you're in. In this case, Y has to be -4 because we are in quadrant 3. All right, so we're all set now. Now I can say sine of theta is Y over R, so that's -4 over 5. And tangent of theta is 4/3. Y over X.
Which triangle?
It would be this triangle. So this distance would be 3, this distance would be 4, and that distance is 5. Except we need to remember, because of the quadrant we're in, it's kind of weird to say we have a distance of -3. The distance is really 3, but the X value is -3. Other questions?
So pretty much theta is the acute angle.
No, theta is this angle. If I'm dealing with an acute angle, sine, cosine, and tangent are always all positive. Because if I have an acute angle, I'm in quadrant number 1. Okay. Again, this angle in here, this acute angle in here, that's called the reference angle. Extremely important. And again, we're not going to get to it today, but we'll definitely talk about reference angles on Friday and how we use them. All right, so what I want to end with today is I'm going to give you a very important angle. I'm going to give you this angle theta right here. Well, you should know how much that angle is. That angle is 90 degrees. Give me a point on that ray, any old point that you like. 5 is not a point. 5 is a number. 0,5 is a point. All right. 0,5. So in this case, X is 0, Y is 5, R is 5 also. Why would R also be 5? Because I would do 0 squared plus 5 squared and then take the square root. Or R is the distance from here to there. That distance is 5. All right. What's the sine of 90 degrees? 1, because it's y over r. It's 5 over 5, which is 1. What's the cosine of 90 degrees? X over r, 0 over 5 is 0. And how about the tangent of 90 degrees? 1? 0? Undetermined? Undefined? It's y over x, which is 5 over 0. What's 5 over 0? Undefined. You cannot have 0 on bottom of a fraction ever. It's undefined. Alright, then I'm going to give you my next favorite angle. My next favorite angle is that one right there, which is 0 degrees. Here's a point. Give me some numbers. 5, 0. All right, we're fixated on 5 today. 5 comma 0. So x is 5, y is 0, and r is also 5. All right. What's the sine of 0 degrees? 0 over 5, which is 0. What's the cosine of 0 degrees?
0.
Not 0.
1.
1, because it would be x over r. 5 over 5. 5 over 5 is 1. And tangent of 0 degrees. Tangent is y over x. 0 on top is okay. 0 over 5 is 0. Alright, so we're going to build our bigger chart. And we're going to have sine of theta, cosine theta, tangent theta. We're going to have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. All right, so the sine of 0 degrees, we just figured it out. What was the sine of 0 degrees? 0. Sine of 30, you're supposed to have memorized already. Sine of 30 is 1/2. Sine of 45 degrees? Root 2 over 2. Sine of 60 degrees? Root 3 over 2. And sine of 90 degrees, we just figured out up here, 1. So there's the sine chart. Cosine simply goes backward. Cosine starts at 1, and then it goes square root of 3 over 2, square root of 2 over 2, 1/2, and then 0. So if you know the sine values, for free, you get all the cosine values. Just write them backward. And then how about the tangent values? We simply divide. What's 0 divided by 1? 0. This one's the hard one. Let's skip it. Square root of 2 over 2 divided by square root of 2 over 2. 1. 1 divided by 0 on the end. Undefined. Can't have 0 on bottom. This one is a little bit of a pain. Square root of 3 over 2 divided by 1/2. You flip and multiply. You end up with square root of 3. And then this one, it's probably best just to remember it. It is root 3 over 3. That is correct. All right, so most of that chart you already memorized. So now you get a few more to fill in. And that same teacher who went to Albany State Teachers College, here's what he taught me. Well, he taught the whole class. He taught us to remember the sine. And here's how sine works. Sine goes square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. So you can remember the sign by simply going 0, 1, 2, 3, 4. Can everybody go 0, 1, 2, 3, 4? No? That gives you sine. Once you have sine, you write them in the opposite direction. That gives you cosine. And then once you have both of those, you can simply divide. Alright? So again, something you need to go home, memorize. You should know that by Friday. See you Friday.